Right, and without any delay, I'd like to introduce you to Joshua from Cambridge Mechatronics. And I believe Joshua is using shape memory alloy actuators for focus compensation in XR displays. I believe that's what you're going to talk about today. So,
That's brilliant. All right, I'll crack on. Nice to be here and talking today. And yeah, like just mentioned, I'm talking about Cambridge Mechatronics' shape memory alloy actuators. So first, a little bit of a overview of Cambridge Mechatronics. So we're the world leader in the design and the control of shape memory alloy actuators, and I'll come on in my talk to give you a explanation of what SMA, shape memory alloy, is. We use these actuators to enable high-performance miniature actuator systems, and primarily we're shipping our kind of core business today is in the smartphone camera industry. So we use these miniature actuators. You can see a picture on the right-hand side of one of our actuators to do both image stabilization and autofocus, where we're moving various components to improve the performance of the camera. When you think of Cambridge Mechatronics, we kind of are a full system provider in the sense that we do the mechanical design. We are a fabless semiconductor company, so we provide the driver chips, and critically, we provide the control firmware, which determines the control of the actuator itself. We work globally, so we license our technology to manufacturing partners, predominantly in Asia, who will go on and manufacture the actuators and launch those into end products. So far, actually, we've already had a lot of success in the smartphone camera industry. We've shipped more than 50 million actuators now, starting our kind of big success was 2019 when we made it into the Huawei P30 Pro. And then since then, we've shipped in several high-end phones every single year since then, getting us up to our 50 million units. And now we're really starting to look at new industries, new applications for actuators, and XR displays is one that's really exciting for us. So SMA, what's it used for? It has some really cool applications that other companies are putting this fantastic material to use. One of which is the Mars rover tires. So in this case, the material, which is an alloy of nickel and titanium, is being used for its super elastic property. And in this case, it can undergo a very large strain and then recover its original shape without being damaged. And obviously, on Mars, where there's no atmosphere, having a pneumatic tire susceptible to punctures would be a very bad idea. And so that's a really quite a niche use case. But I have recently seen a company bringing a bike tire with SMA to market, hopefully later this year. And then in the medical world, stents also often using nitinol, which is the particular alloy that we also use, this nickel titanium blend, again for the super elastic property. So I mentioned this super elastic property. Actually, CML is using something slightly different, which is called the shape memory effect, which is where the material can deform through relatively large strains, but then recover its original shape when it goes through, is reheated. And it does that by going through a phase transformation. So in its hot state, the material has an austenitic structure, which is cubic, and generally that's the compact state. When the material cools down, it transitions its phase into a martensitic phase. And in this phase, it can undergo relatively large strains. And so if you load it with a force, you'll see that strain. And then you can recover the original shape by heating it up when it recovers back to the austenitic phase. So some of the key properties of the material itself that we're using are the strain that it can go through. So we use the material in the form of very thin wire, and